Welcome to 56-Bit Cloud Cafe, your go-to destination for all tech topics in the cloud. I'm Athir Zalat.
And I'm Patrick Camilleri. And together we'll be addressing various cloud topics.
Hello everyone, and welcome back to the final episode of our DynamoDB series. Today, we will be discussing best practices and some of the advanced features that DynamoDB offers. This episode is packed with tips and tricks to help you optimize and scale your applications. So let's start. Before, we've covered a lot of ground on DynamoDB's features and use cases. But let's step back and talk about general best practices. What are some general best practices for using DynamoDB efficiently?
We've mentioned some of these in previous episodes, but it's always good to iterate some best practices. The first, probably most important one you will be able to do when developing and designing for DynamoDB is to make sure that your access patterns, the way you access the data, aligns with your data model. So when you are creating a table or creating secondary indexes, you should choose primary keys, meaning those unique keys that allow you to retrieve data, which might also have a sort key in them, as we said. So designing those primary keys with the query in mind, with the access pattern in mind. It's also might be important to choose those primary keys, those partition keys, let's say, the ones that actually split your data under the hood. It might be a good idea to choose them properly to evenly distribute your data. So if you have partition keys that allows a lot of data to be stored in one partition whilst very little data stored in a different partition, that's what we call a hot partition. A partition which is used a lot more than other partitions. And hot partitions really reduce the speed of DynamoDB. So it's important to choose partitions using those primary keys, to choose them properly, to have an evenly distributed set of data. You should but rather most of the time you should not use scans, but rather you should use queries. We've said this before. Scans are very slow and costly. And you can denormalize and reduce the complexity of your data, or you can go towards the opposite, where you have very complex values. This is known as denormalization, where you join all the data into one item, allowing you to have a simple retrieval without requiring joins. So it's up to you which one to choose of those two methods. And finally, if there are large objects like images or large documents, you might want to put them in a different type of store, something like an object storage system like S3. Then you can still reference them in DynamoDB by having the S3 key, the actual location inside S3 of where your item is. But the actual object will not be in DynamoDB because S3 is much cheaper.
And now let's talk about cost. Cost is always a consideration when using cloud services. How can you optimize DynamoDB for cost efficiency?
Yes, so the last point where you remove large items and put them in an object storage like S3, that is a great cost optimization strategy, apart from being a performance optimization strategy. It's important to choose the right amount of throughput that you will need. So this is the amount of reads per second and writes per second you will require. And if you cannot decide, then you can use the auto-scaling features of DynamoDB. And there are even the purely serverless features allowing you to not care at all about scale. You just let it manage it for you. This is known as on-demand billing, and it may be slightly more expensive, but it allows you to truly master the scaling out and in of your database, especially when your access patterns are unpredictable. Other methods might be a bit more efficient, but then you need to have more information to be able to use them.
Okay, perfect. Now DynamoDB has some powerful advanced features that can unlock new capabilities. What advanced features does DynamoDB offer such as DynamoDB Streams and Transactions.
DynamoDB offers a lot of advanced features. One of them is, as you mentioned, streams. So DynamoDB Streams allow you to capture changes, updates, creates, deletes inside the table, and it allows you to then trigger other things like Lambda to be able to process the data that has changed. This is great for processing, analytical queries and building serverless applications. It can be a trigger for downstream applications that require changes to the data. Transactions, which you've mentioned, allows you to do something very similar to transactions in SQL databases. So transactions are basically the same thing. It allows you to do data consistency across multiple tables with what is known as an atomic write. A write which ensures that all tables are written properly before it lets you kind of use that information, right? So the writes happen and you are sure that they will happen before it comes back with a success message. That's a transaction that allows you to write multiple things in multiple tables at the same time.
Perfect. Now, serverless and real-time data processing are major trends nowadays. How can you leverage AWS Lambda and DynamoDB Streams for real-time data processing?
As we said, DynamoDB Streams allow you to trigger Lambda to do whatever you want. Lambda is ultimately a compute service where you can put in your code. Let's say it's Python code, which allows you to do things like, if you have an incoming request in DynamoDB, maybe then you grab that request and action it through Lambda. You can also use it with Kinesis, where you have an integration between Stream and Kinesis, and then Kinesis can do other things downstream.
Now, as applications grow, scaling becomes crucial. Can you share any tips for scaling DynamoDB applications to handle large-scale workloads?
We've already discussed a lot of these best practices here when you have complex workloads, things like denormalization, things like making sure that your access patterns align with your data model, ensuring that your primary key is evenly distributed. All these things are very important for complex queries using local secondary indexes and global secondary indexes. We've mentioned those. One thing which we haven't mentioned is global tables. Global tables allow you to read and write from multiple regions, and that ensures both high availability but also improved performance, because if you have customers coming from two different places, you might want to have the data being read from the closest location, but at the same time you need to have that data copied and cloned from one place to another automatically. Global tables allow that. You can have multiple locations with the same data being updated all the time, and people can read and write from the closest location.
And that concludes our series on DynamoDB. We hope you've enjoyed learning about this powerful NoSQL database and that you've gained valuable insights to apply to your own projects. Thank you for joining us, and be sure to check our other podcast series on cloud technologies. Until then, happy cloud computing!
If you have questions, suggestions, or want to share your feedback, connect with us on social media.
Also, don't forget to subscribe to our podcast and to leave us a review to help others find their way to the Cloud Cafe.